This is section 10.2. We're going to continue our discussion about vectors in three-dimensional. Today we're going to focus on being able to find component form, unit vectors, magnitude, dot product, and the angle between. We're going to finish it up with figuring out if vectors are parallel. Lots of the same stuff we did in the chapter 6 unit. With vectors, we're just going to do them in three-dimensional now. So the first one says, can you find component form and magnitude of the vector v having initial point blah and terminal point blah? So in order to find component form, we have to do terminal minus initial. So we're going to take our ending point and we're going to subtract the beginning one. So 3 minus 3 would give me a 0, 6 minus 4 would give me 2, and 4 minus 2 would give me 2. So that's my component form. To find the magnitude of that, which would be our magnitude double bar, I'm going to square each of them and then square root. So 0 squared plus 2 squared plus 2 squared gives me a square root of 8. And you're totally fine leaving me the square root of 8. You don't have to break that down. The last part says find me a unit vector. So now you're going to combine the two. You're going to take a vector and divide by its magnitude. So the unit vector, just like in chapter 6, you take the vector 0, 2, 2, and you're going to divide by magnitude. But once you kind of give each number that vector, the problem is that you have a square root on the bottom, which is not okay. So we're going to fix that by swinging that square root up on top and dividing by 8 on the bottom. You can even go one step further and kind of simplify these and have it just be square root of 8 over 4. That would be lovely. Next, we're going to do dot product, same as in chapter 6. You just got one more number to worry about, your z variable. So dot product, you want to multiply them and then add. So we're going to do 0 times 4, 3 times negative 2, and negative 2 times 3, for a total of negative 12. Next one says find the angle between. Using these ones, I need to start off finding the dot product on top. So we're going to do some more multiplying. 1 times 3 is 3. 0 times 1 is 0. And 2 times 0 is 0. On the bottom, we're going to do their magnitudes. So we're going to kind of just square each of them like we did above, right there. And then give the square root. So the first one is 1 squared, which is 1, plus 0 squared, and then plus 2 squared. So I've got a total of 5 there, times, and then I've got 3 squared plus 1 squared, which is 10. When I get done typing all of that in, I end up with 64.9 degrees. Standard unit vectors are the same they were in chapter 6. It just had to do with the i's and the j's. We're talking about linear combinations. And then we're just throwing on that extra letter of k for that third dimension that we're dealing with. So it says these vectors are used to represent any vector. And we're just going to be talking about if that's the vector, then it'll be that number with an I, the next number with a j, and the next number with a k. So it's just going to be an ijk kind of a thing. And it's just talking about your horizontal, your vertical, and then your kind of front and back movement. So that into the board and out of the board in order to move in all three dimensions. Last couple, we're going to talk about parallel now. So here's my vector. It's going from this point, because those are parentheses, not bent. So that's a point to a point, which means I need to do component form first. So my vector w in component form would be terminal minus initial, so 2, and then 4, 2 minus a negative 2, and then 1 minus 0 for a 1. That's my w. And now I'm trying to determine if either of these guys is parallel to that w. So parallel vectors were multiples, so I'm just trying to see if this was multiplied by the same thing each time. And this was multiplied by 2. 2 times 2 is 4, 4 times 2 is 8, 1 times 2 is 2. So this one is parallel. To get over to this one, I'd have to do 2 times 2, which is 4, 4 times 2, which is 8, looking good, but then 1 times 4 would need to be to get to a 4, so this one is not. So really kind of just recapping everything we did in 6 with component form, magnitude, unit vectors, dot product, angle between, linear combinations, and then parallel. Lots of topics, but all the same thing as chapter 6, just with a Z on them.